seconds. How do we turn it into decimal?
You put the minutes over 60 and the seconds over 3,600.
And then we just put it all in the calculator, add it all together. Nearest thousandth would be 3 decimal places, so you get 74.137 degrees. Okay, if we have decimal, how do we get to degrees, minutes, and seconds? Well, to get decimal, we divide it by 60. So to undo it, did you say multiply? Okay, so the opposite of dividing would be to multiply. Now the degree part stays. So our answer is 34 degrees. To get our minutes, we take our decimal. If I could write, that would help. 0.817 times 60. So that tells me we have 49.02 minutes. So we keep the 49 minutes, and then we convert the 0.02 seconds. So we take 0.02 times 60. We get 1.2. And how do we answer that final part? Round it. So that would just be 1 second. Now, I don't care if you say 1 second or in your textbook it'll always say 01. I don't care if you have that 0 in front of it or not. It does not matter. Any questions about going back and forth between those two? Then the next piece we want to talk about is coterminal angles. In the past, probably any angles you only saw positives, and we know now we can have negatives. The biggest you saw was probably 360 degrees, because that's all the way around. But it is possible, if you take something and start spinning it, can it go around more than once? Yes, so then it has spun more than 360 degrees if you continue to go around. Every time it goes around the circle, it spins 360. So when we're talking about these, we typically want like the nicest angle we can get. We prefer something between 0 and 360. Those are called coterminal angles. So coterminals are just things that end in the same position. For instance, okay, if I had like a 45-degree angle, 45 degrees, if I graphed negative 315 degrees. We talked about yesterday. What does a negative mean? How do you get a negative angle? It spins downwards. So if we came down 315 and there's 90, 180, 270, 315, it ends the same place. So 45 and negative 315, those numbers are different, but if I graph them, they end at the same spot. Or if I did 405 degrees. Okay, 405, so 360 is all the way around, and another 45. Those are all coterminal. They're different angle measures, but if you graph them, they end at the same spot. The terminal side ends at the same spot. That's coterminal. We prefer to get a number between 0 and 360. So to do that, we would just add or subtract 360. If you have negative 315 and you add 360 to it, you get 45. If you had 405 and you subtract 360, you get 45. What I just drew up here, these are what are called standard position, where your vertex is at 0, 0, and your initial side is the positive x-axis. And so typically standard position. The final term that you're going to hear is quadrantal. Those are your angles that end on an axis. So 0 degrees would look like this. 90 degrees, your terminal side is on the positive y-axis. 180 would end on the negative x-axis. 270, 360. So if the terminal side is on the x or y-axis, that's called a quadrantal angle. All right, so let's find the angles of least possible positive measure coterminal with each angle. So to get coterminal, we are just adding or subtracting 360. So if I start here, 1,106 minus 360 gives me 746. Is that the most simplified we can get? No, so you might have to subtract multiple times. Okay, if I subtract 360, gives me 386. Is that small enough? Nope. So do it one more time, and that gives me 26. Okay, so in other words, if you were going to draw this in standard position, the terminal side ends at 26 degrees. How many times did I subtract 360 off? I subtracted 3 times. So essentially, this original thing went all the way around 1, 2, 3 times and came all the way back. But in terms of the graph, it looks the same as if you had just done 26. All right, what would I do with my negative 150? It's negative, so we would add 360. And get 210 degrees. I didn't ask for a picture, but you could certainly draw one. If we think about this. This is 90, 180, 210 would be about here. So 210 would spin this way, negative 150 spins this way, but either way the terminal side ends at the same spot. Negative 603, so if we add 360, that's not enough. You just get negative 243, so we have to add 360 twice. And we get 117 degrees. So finding a coterminal angle is very helpful. We want to deal with the smallest positive number that we can. Any more questions? The last thing I want to touch on, sometimes we need to do some conversions in here. So we're going to do just a couple conversion problems right now. We will do more later on in coming chapters, but just introduce it. So a wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of the wheel move in 5 seconds? All right. There's different ways of doing this. I prefer to set it up. Do you do unit conversions in your science classes ever? You've never done that? Okay. This is how my mind works. I have some people that don't need to do this, but I am a visual person, so I need to see it. So we know it makes 270 revolutions per minute. So I set it up as a fraction. 270 revolutions per means divided by minute. Okay, and I include my units with this. I need to get it into degrees. So you may not have to set up these fractions. Some people just can think through the conversions, but this helps me a lot later on as well. If I want to convert to degrees, what does a revolution mean? All the way around. How many degrees is that? All the way around a circle. So what that means is 1 revolution is equal to 360 degrees. So we can set this up, they're equivalent. I need my revolutions to cancel out. So if one's on top, I can cancel it if the other's on the bottom. So I'm going to say 360 degrees is equal to 1 revolution and set that up as my next fraction. Because then, if I'm thinking about my units, revolutions on top and bottom drop out. Okay, I also know I'm talking about 5 seconds, but I am in minutes. So let's do a conversion. 1 minute is equal to what? Do I want my minutes to be on top or bottom to cancel? Top. So I'm going to say 1 minute on top, 60 seconds on the bottom. And if I do that, minutes on top and bottom cancel. What's the last piece of information we have? In the problem, it tells me it's moving for 5 seconds. So I'm just going to take it times the 5 seconds. And that's helpful because seconds on top and bottom cancel. My question was through how many degrees? Notice degrees is the only unit I have left. So now we just work this problem. So we have 270 times 360 divided by 60 and times 5. So we get 8,100 degrees. Why don't you guys try this? Practice. 480 revolutions per minute. We know 360 degrees is 1 revolution. We know 1 minute is 60 seconds. We're going to spin for 2 seconds. And what did you get? All right. Any questions there? So, this is technically the end of the section. So here is the full assignment. Yesterday I gave you up through 69, so there's a few more problems. I would like to start section 2 today as well. It's kind of like 3 days I want to do 2 sections. So I'll let you guys pick. If you. So, first thing, we don't use this a ton, but there are sometimes it is a helpful shortcut to remember. So in geometry, you spent a ton of time talking about 2 parallel lines cut by a transversal. So 2 parallel lines, transversal is just any line going through them. To make things easy, I'm going to number these angles. So let's say this is 1, 2, 3, 4, 5, 6, 7. Do you remember what alternate interior angles are? So,
4 and 5, right?
Opposite sides of the transversal in between the parallel lines. So angle 4 and angle 5. Any others? What's true about their measures? It's not going to say congruent. They have the same measurement. Out of all the relationships that come up, this is probably the one that we'll see the most. The alternate interior. Alternate exterior. So it's opposite sides of the transversal, but outside the parallel lines. So what would those be? 1 and 8, 2 and 7. And what's true about those measures? consecutive, so that means same side of the transversal, interior, inside the parallel lines. So that would be 3 and 5. What's the other one?
4 and 6.
Mm-hmm. What's true about those measurements? Yes. Corresponding, that means the same position. So angle 1 is above the parallel line to the left of the transversal. What's the other angle that's above its parallel line to the left of the transversal? Mm-hmm. We would have angle 2 and angle angle 3 and angle 7, angle 4 and angle 8. And what's true about those measures? And final relationship, vertical angles. Remember, vertical angles make an X. So it'd be like 1 and 4, 2 and 3, 5 and 8, 6 and 7. And what's true about those measures? I am not going to ask you to tell me the word, I'm not going to say angle 1 and angle 5 are what, and expect you to write the word. It's more that if we see a picture, we can use these relationships to help us figure out unknown things. So it's worth our time to review, but not something we'll spend a ton of time on. So let's look at an example. I'm going to find the measures of all the angles, 1, 2, 3, 4, in this picture. So the only ones I gave us variables for are 2 and 3. What would be true about angle 2 and angle 3? Mm-hmm. So we say 9x plus 9 plus 7x minus 5 equals 180. Combine like terms. 16x is 176. Divide by 16. And we get 11. So now I need the measures of all these angles. Measure of angle 1, 2, 3, and 4. So if I plug 11 back in for angle 2, 9 times 11 is 99, plus 9 is 108. If I put it into angle 3, 77 minus 5 is 72 degrees. Then what would angle 1 have to equal? Because of vertical angles, it's across from it, so it would be the same. And angle 4?
Also,
Its corresponding angles, it's in the same position as 2, so it would have the same measure. So that's more like the type of problem I would give you. Just a picture and ask you to find some missing unknown. You don't have to label what the relationship is, just be able to solve for it. All right. Triangles. What do all the angles in a triangle add up to?
180.
So that's the next important piece. The measures of the angles in a triangle sum to 180. They add up to 180. So if I tell you the measures of two angles in a triangle are 33 degrees 12 minutes and 26 degrees 35 minutes. Find the third angle. What do we have to do first? So from yesterday, we add our minutes, we add our degrees, and then what would we do?
subtract from 180.
Okay, so this is like 180 degrees in 0 minutes. So we have to borrow, make it 179 degrees, 60 minutes. 60 minus 47 is 13. 179 minus 150, sorry, minus 59 is 120. So the third angle is 120 degrees 13.